Welcome back, everybody. Ready for another deep dive with us?
Always.
This time, we're tackling something I always find super fascinating.
Yeah.
The accelerating expansion of the universe.
Okay.
Why is the universe expanding faster and faster? You'd think things would slow down after the Big Bang, right?
Right.
But it's like hitting the gas pedal on a cosmic road trip.
That's a good way to put it.
Speeding up.
Yeah, and that's where this mysterious force called dark energy comes in. Seems to be driving this acceleration.
So dark energy is like the foot on the gas pedal.
Exactly.
Okay, got it.
And there's new research from the Dark Energy Spectroscopic Instrument.
What?
DESI, they call it.
DESI.
Okay. And it's really making us rethink what we know about dark energy.
All right, so before we get into all the mind-bending stuff,
Sure.
let's set the stage.
Yeah.
DESI.
Uh-huh.
It's not some fancy new coffee machine, is it?
No, definitely not.
Okay.
Think of it as a massive detective agency. Except instead of solving crimes, it's mapping the universe.
I like it.
There's this team of over 900 scientists,
Uh-huh.
and they're using this incredible instrument on a telescope in Arizona to map millions of galaxies and quasars.
Quasars, now those sound cool.
They are?
What are those again? So imagine a black hole
Okay.
that's 1 billion times more massive than our sun,
Whoa.
just gobbling up everything around it.
Okay.
That's a quasar.
All right.
Incredibly bright, incredibly powerful,
I can imagine.
and really far away.
So they're old.
Ancient. Like beacons from the early universe.
Okay, so DSI is using these quasars and galaxies, which are billions of light years away,
Yeah.
to understand why the universe is expanding faster.
Yeah, it's ambitious.
That's super ambitious. But why quasars specifically?
Well, they're so bright
Okay.
that we can see them from huge distances, and that lets us trace how the universe has expanded over time.
It's like looking back in time.
Exactly. When the universe was much younger.
And what they found is shaking up what we thought we knew about gravity.
Oh, really? You know how we always wondered if gravity works the same way across the universe?
Mm-hmm.
Well, DESI just confirmed that Einstein was right all along.
Yeah, Einstein's theory of gravity.
It's held up so far.
I know, right? It's been tested in our solar system, but never before on such a vast scale.
Yeah, that's true.
DSI's findings show that even across billions of light years, gravity behaves as we understand it.
That's a huge win for Einstein.
It is.
But wait a minute, you mentioned something about dark energy earlier?
Yeah.
I thought DESI's findings were challenging some of our ideas about that.
They are, and this is where things get really interesting.
Okay.
You see, the traditional view of dark energy is that it's constant.
Constant.
Like a steady force pushing everything apart.
Gotcha.
But DESI's data is suggesting that maybe it's not.
Hold on.
Yeah.
Are you saying dark energy is changing?
Ah,
It wasn't always the same.
It seems that way.
What would that even mean for, well, everything?
That's a great question, and that's what we're going to explore next. Imagine dark energy,
Okay.
not as a constant push, but as a force that's been gaining strength over time,
Whoa.
like a cosmic engine
Yeah.
revving up.
So it's getting stronger.
That's what it looks like.
Wow.
This dynamic dark energy, as it's called, could totally change our understanding of the universe's fate.
Okay, I am officially intrigued.
But you?
So we're talking about a universe where dark energy isn't just some background hum.
Right.
It's like a crescendo.
It is the massive shift.
It really is. And it throws a lot of our predictions about the universe's future into question.
Totally.
So, okay, before DSI, what did we think was going to happen? What was the classic ending?
To the universe.
Yeah.
The big freeze.
The big freeze, okay.
Essentially, as the universe expands, everything gets further and further apart.
Okay.
And things cool down.
Makes sense.
Stars eventually burn out, matter spreads out,
Yeah.
and the universe becomes this cold, dark, empty place.
Oh, wow. So that's where we thought we were headed.
Pretty much.
Just a slow fade to black.
Yeah, basically.
Kind of a bummer ending.
Yeah. Not very exciting.
But with this whole dynamic dark energy thing,
Right.
maybe we're in for a much wilder ride.
We might be.
Okay, so what happens if this cosmic engine keeps revving up?
Okay.
What's the alternative ending?
So there's a theory
Yeah,
called the Big Rip.
the big rip. Okay.
If dark energy gets stronger and stronger, the expansion of the universe could accelerate to a point where it overcomes all the other forces.
All other forces, so.
Gravity, electromagnetism,
Okay.
the strong and weak nuclear forces, everything.
So not just galaxies drifting apart,
No.
but actually everything being torn apart.
Exactly.
Stars, planets,
Yeah.
even atoms themselves.
That's the idea.
Whoa, okay, hold on. So imagine
Yeah.
the fabric of space-time
Yes.
stretching
Stretcher.
so rapidly that it eventually rips apart
Yeah.
and takes everything with it.
Everything. Okay, that's a lot less of a gentle ending
It is.
than a freeze.
It's more like a cosmic shredder.
Yeah. So is that what DSI is telling us is going to happen?
Not necessarily. I mean, we need to be careful about jumping to conclusions.
Right. Yeah.
DSI is giving us clues.
Yeah.
But it's still early days.
Sure.
You know, they're analyzing an incredible amount of data,
Yeah. Billions of years worth.
billions of years worth, and they're still collecting more.
So it's like we've got a few pieces of this giant cosmic jigsaw puzzle,
Mm-hmm.
and we're still figuring out what the whole picture looks like.
Exactly.
Okay, so what's next for DSI?
Well,
What are they looking for in all that data?
so one of the big things is to try to pin down exactly how dark energy has changed over time.
Okay.
Have we been seeing a steady increase?
Okay.
Were there periods where it was weaker or stronger?
Gotcha.
The more data they collect, the sharper the picture will become.
And I remember you mentioned neutrinos earlier.
Yeah.
What role are those playing in all of this? Neutrinos are so fascinating.
What's so cool about them?
They're incredibly tiny,
Okay.
and they barely interact with anything.
So, like, they're just out there doing their own thing.
Yeah, but they're also incredibly abundant.
Abundant.
Like trillions of them.
Are passing through you right now.
Really? I had no idea.
They're like cosmic ninjas, just sneaking around the universe.
I love that cosmic ninjas.
Right. And their mass, even though it's tiny,
Okay.
affects how gravity works on a large scale.
Oh, interesting.
And DSI is helping us put tighter and tighter constraints on neutrino mass,
Okay.
which can tell us a lot about the evolution of the universe.
So DSI is helping us understand not only this mysterious dark energy,
Right.
but also these elusive neutrinos?
Yeah.
It's like a 2-for-1 cosmic mystery deal.
Exactly.
What's the timeline for all of this? When can we expect to see more results?
Well, they're actually gearing up to release new findings. Oh, really? Based on the first 3 years of observation.
Okay. And when can we expect that? March.
Ooh, March!
Mark your calendars.
I will. Can't wait. More pieces to the puzzle.
Yeah.
Maybe some answers.
Yeah.
And probably even more questions.
Probably.
But before we get ahead of ourselves,
Yeah.
I think it's worth pausing to appreciate just how mind-blowing all of this is.
I agree.
I mean, think about it.
Okay.
We're using light from objects billions of light years away
I know, it's crazy.
to understand the fundamental forces that are shaping the universe.
Shaping the universe. It's amazing.
And we're talking about things like dark energy
Yeah.
and neutrinos.
It's
It seemed like science fiction just a few decades ago.
Yeah, it's mind-blowing.
It really makes you feel small in a good way.
It does.
So we've got this dynamic dark energy potentially driving the universe towards a big rip.
Right.
But it's not a done deal, is it?
No, not at all.
What are some other possibilities?
Well, one of the big unknowns is whether dark energy will continue to increase in strength.
Okay, so what if it levels off?
Exactly. What if it plateaus at some point?
Okay.
Or even starts to decrease?
Oh, so maybe instead of a big rip, we get a big slowdown.
Maybe. Or maybe there are forces at play that we haven't even discovered yet.
Oh, that's true.
The universe is full of surprises.
Yeah, that is true.
We're just starting to scratch the surface of its mysteries.
That's both terrifying and exhilarating at the same time.
It really is.
Well, before we wrap up,
Okay.
any final thoughts for our listeners as they contemplate the fate of the universe? It really is a lot to think about.
I know, right?
We've gone from quasars to the Big Rip,
It's a lot.
from Einstein to neutrinos.
Mm-hmm.
It's been a real cosmic roller coaster ride.
It has.
But before we get off,
Yeah.
any final thoughts for our listeners as they contemplate the fate of the universe?
You know what I find most fascinating about all this?
What's that?
This idea that dark energy might be dynamic,
Yeah,
that it's actually changing over time.
right.
I mean, it really challenges us to think about the nature of the universe itself.
In what way?
Well, is it static and unchanging?
Okay.
Or is it evolving,
Yeah.
even at the most fundamental levels?
It's almost like the universe is a living thing,
Yeah,
constantly growing and changing.
that's a great way to put it.
Dang.
And it raises so many questions.
Like what?
If dark energy is evolving, what does that mean for the laws of physics?
I see what you mean.
Are they constant?
Right.
Or could they be changing too?
Whoa, okay, so are you suggesting
What's that?
that the rules of the universe
Uh-huh.
might not be as fixed as we thought?
Well,
That even things like gravity might be in flux.
It's definitely a possibility worth considering.
Wow.
And, that's why research like DSI is so important.
Yeah.
It's not just about mapping the universe. It's about understanding the very fabric of reality.
It's like we're trying to read the universe's source code.
Exactly.
Line by line.
And every new discovery is like unlocking a new piece of that code.
That's a really cool way to think about it. So as we wait for more results from DSI, what's something you think our listeners should keep in mind when they look up at the night sky? What's the big takeaway?
I think the big takeaway is just to embrace the mystery.
Embrace the mystery.
Don't be afraid of the unknown.
Okay.
The universe is a vast and complex place, and we're only just beginning to understand it.
Yeah, that's true.
But with every new discovery, with every question we ask, we get closer to unraveling its secrets.
So keep exploring.
Keep exploring.
Keep learning.
Keep learning.
And keep wondering.
Absolutely.
Beautifully said. Thanks for joining us on this incredible deep dive.
Yeah, this was great.
Until next time, keep those minds open, keep looking up, and keep exploring the universe within and around us.